My name is Abdul Muiz Abdul Rahman, TP072327. So our assignment is about disease classification with the use of CNN. So there's task one and task two. Task one is used to use the pre-processed image, and traditionally, yes, the disease healthy was unhealthy. Although my data set has 3,200 images with 46 different diseases, in task one I have not guessed each individual disease because it's uh it's very inaccurate. But for task two, I have improvised and I have pre-taught a model called efficient net to learn what disease is in per image. Okay, before I go into the GUI itself, let me show you my images. So these are my pre-processed images which I pre-processed earlier. So this is just the testing files which I'm going to test using today. So in most of these images, some of them are healthy, versus some of them are unhealthy. Also, how I pre-process them is by contrasting, highlighting using vessels, and also cropping to fit the circle. And also, I used FOV masks to make sure it's a perfect circular retinal line. Okay, moving on to my assignment now. Okay, so I'm going to run task one now. So and right now, if okay, let's choose a disease that looks really unhealthy. Okay, right now, if when we see this, right now when we see this, we can see that image number one is 100% unhealthy. So let's open it and let's run task one, and we can see it's unhealthy. Task one is unhealthy. Also, my report is supposed to look like this, but since a few errors in the GUI from my part, I couldn't get the report out for the task one, the traditional method. This is what it's supposed to look like, where it says unhealthy, unhealthy, and then healthy. So this is my report for task one. And moving up to task two, which is the better version of this topic. So in task two, right, we can guess every individual disease, even if it's multi-labels. So let's go ahead and upload an image. Okay, let's go image number 253, and let's run it. Yes, as we can see, the diagnosis is unhealthy. The predicted disease is MYA, and the point which highlights whether it has the specific label is the threshold. So here we can say the threshold is 0.18. So if the percentage accuracy is above 0.18, which means it's above 18%, that means it's positive for that specific label. And right below it, we can see MYA. So even for it, it's above the threshold. And it shows also the probability for some other diseases. But as we can see, it's below the threshold, and so it's not positive and it does not exist in this retinal image. And going down, we can also see the GradCam heat map, which shows the concentration of where the disease is located. So if we go here, we can see clearly that there is a disease located here. All right. Okay, so let me run another task. Okay, let me go through one more picture. Okay, let's do something that looks healthy. Okay, most of these the last few files look healthy, so let's choose 495 and run it. And as we can see, 495 is healthy. It's because the disease risk and any other labels is below the threshold. And let's run one final task. Okay, let's go with the green one. Okay, for this, the diagnosis is unhealthy. And as you can see, as I have previously mentioned, if the percentage accuracy is greater than the threshold, that means it checks positive for that specific label. For example, disease risk label and image label both check positive, and disease risk is what determines if it's healthy or unhealthy. If it's below the threshold, it's healthy, and if it's above the threshold, it's unhealthy. And going down, we can again look at the heat map. And on the right, I have indicated that the red dashed line indicates the decision threshold, which identifies between positive and negative. And more or less, that's what I did for my GUI. And thank you.
Hi, my name is Aman Rashid, TP073098. Today I'm going to present my COVID X-ray integrated system, where I will upload the X-ray of lungs, and it will detect if it's COVID or not COVID, or let's say normal. Here I have the GUI for Team AI Tigers. Me and my teammates, Yusuf Zaitoon, Joshua, and Moez. All of their work is integrated under one GUI. So I will present mine. So mine is basically I upload one random X-ray, which is for now I'll select COVID 0. And then I'll do run both tasks. The both tasks we were supposed to run was task 1 was supposed to be without AI, where we have different filters and we predict COVID based on that. And as you can see, it says COVID-like abnormalities with different data here. And here on the task 2, we can see COVID detected, confidence score 99%. So this is based on the fuck. Oof. Hi, my name is Aman Rashid, TP073098. Today I'm going to present my work on COVID X-ray integrated system. Here we can see we have uploaded chest X-ray. Here we're going to upload the chest X-ray. Then we will have two outputs, task 1 and task 2. In task 1, we were supposed to use different filters to check if there's COVID or not. And in task 2, we basically train AI on certain data set, and then we test on unseen data. So right now I'll upload an image which is never seen by the model. So to predict, so all the X-rays here are never seen by the AI model. So I can just upload it here and run both tasks. So this is basically a COVID one. As you can see, task 1 says COVID-like abnormalities. So this is without AI, without the AI learning. But here you can see it detects COVID and it's 99% confident. So this is for the COVID one. Now I'll try to upload I'll try to upload a normal one. Let's just choose this one. Open. So this is a normal X-ray, and I'll try to run both. So here we can see that it even says likely normal. This is without AI. This is just the filters. And here on the task 2 output, it's a confidence score. And there's also a batch mode where we can upload up to 5 different X-rays, and I'll try to upload. I'll try to put both of them together and check if they run accordingly. Wait. So yeah, as you can see, I uploaded 2 files, COVID 0 and normal 16. These files are never seen by the AI as well. So we'll run batch analysis and we will unfold result 1 and result 2. As you can see, it's still working. Normal and normal. And I also want to show you the part where I have implemented some CSS for good looks. So this is basically the same GUI, which is run under the whole team's GUI, but this is the one done by me before, combining my GUI. So as you can see, it's COVID detected, and we can see the red line saying that it's COVID and COVID-like abnormalities. It works the same way here as well, the batch. So as you can see, it runs. It says COVID detected 99%, COVID detected 99%. And here's my and here in the outputs, we can see that I got the best best model. So basically, I ran 20 epochs, and here you can see the train loss of each epoch and accuracy as well. So it's saved in Excel file and also in JSON file and also in text document. So as we can see, best save model here. It's right here with 91% accuracy, and we can see the average result here with accuracy of 95%, with loss of 0.1361 and F1 of 0.95. Yeah, that's it. Thank you.
Hello, sir. I'm Yusuf Zaitoun, and today I'm gonna present my GUI for the Indian diabetic retinopathy. So basically, I'm gonna press here to upload the image. These are like just random test images that have never been trained before. So I'll just choose one, and then I run them all. This is my task 1, task 2, and task 3. Task 1 is about image pre-processing. Task 2 is the training and detecting the DR and the DME. And task 3 is the localization. This is the disease grading, and this is localization. So this is the output of the image, the pre-processing, and this is the final output. It says yeah, DR is yes. This is without any training, just pre-processing. For the second task, this is the DR 0, and the DME is like no DME at all. And these are the percentages. For the localization, as you can see, this is the heat map, and this should be DR, and this should be DME, and these are the values. That was it for me, and thank you, sir. Okay, let's do another one. So we take this. Let's say we take this picture, image, and then we run it. This is going to be the task 1. Because here the DR is yes, and this is the risk, bright, and dark prop values. Here the DR is 2, and the DME, like there's no DME. These are the gradings for the DR and DME. The DR starts from 0 to 5, and DME starts from 0 to, DR starts from 0 to 4, DME starts from 0 to 2. But in this picture, in this image, there is no DME, but the DR is 2. And this is the localization, and kind of detected this is the heat map, and it's kind of detected the diseases. That was it for me, and thank you so much, sir.